Okay, guys. We are starting chapter 6. Okay. I'm not saying everything's done on the calculator, but there are definitely going to be parts of this chapter that you want the calculator there by your side to help you do things. Not quite so much today, but we can also talk about how to use the calculators to help you in certain instances too. So, as we start into this roots and radical expressions, this chapter, there's lots of square roots, cube roots, fourth roots, okay? You learned some pieces of this back in Algebra 1. Or let me rephrase, let me not use the word learned. You were exposed to some pieces of this in Algebra 1. At what level you learned it, I don't know. That's an individual question there. But we are looking, I'm going to start by, let's just review some properties of exponents. And this first one that you can't see actually says a to the power of 0. Okay, that's the part you can't see there, and that's the important part to know. So what is the rule? Anything raised to the power of 0 always equals 1. Would your calculator tell you that as well? Yeah, it does. If you put in 5 to the 0 on your calculator, you get 1 back. Okay, so, as long as you have a calculator by your side, if you forget that, you can still, double check yourself. Let's see. Do you guys remember this? When the bases are the same and you're dividing, keep the base the same and do what with the powers? Subtract. So that's when you're dividing, right? When you divide with exponents, you end up subtracting. What about when you're multiplying then? Yeah, when the bases are the same, you keep the base the same and you add the exponents. Okay. Remember, negative exponents are not usually very appreciated. Anytime you're told to simplify something, you're not allowed to leave a negative exponent. And so in order to get rid of a negative exponent, it moves to the denominator. Now, and on the flip side of that, if you have a negative exponent in the denominator, that means it's going to move to the numerator. Okay? So in order to get rid of negative exponents, you flip it across the fraction bar. Okay? I think in middle school I remember teaching it as like the magic line. Okay? It was that magic line that when you flip it across, it changes the exponent from positive to negative or negative to positive. Hey, when you're teaching it for the first time to kids for the first time in middle school, it works. Okay. Now, when we have a product here, and this is in parentheses, it's AB raised to the power of n. Okay, as long as this is a product or a quotient, what does that n go with? It has to go with each piece or each factor inside the parentheses. So this is a to the n, b to the n. Same thing is true if it is division. If it's a over b raised to the n, that n goes on the a and it's the power on the b. The time that rule does not apply is when there's adding inside the parentheses. Then it turns into a FOIL problem. Okay? So this power can just it's kind of like a distribute in here, as long as it's just either multiplying or dividing. Okay? A power raised to a power, multiply. Okay? And then here, a to the m over b to the p, all raised to the n. Notice, what's that n have to do? It has to go with top and bottom. So it's a power raised to a power here, m times n, on bottom. Power raised to a power, p times n. Okay, so those are some basic exponent rules. They should all seem familiar at least. Can I at least say that? They're familiar? Not sure had I given you an exponent test the minute you walked in how many would have passed it, but they should sound familiar to you. So in example 1, let's do some practice here. Simplify and rewrite each expression using only positive exponents, which is essentially implied when they say simplify. So on A, 5a to the third times negative 3a to the negative fourth. Thoughts on what we do? All quiet. No guesses? Okay, so I'll say yes and yes. First of all, are we going to add the exponents? Okay, if we look at the a parts, it's a to the third times a to the negative fourth, right? And so what happens when you're multiplying and the bases are the same? Right over here. You keep the base the same and add the exponents. So at that point, what is 3 plus negative 4? Negative 1. So my a part is going to be a to the negative 1. What about the 5 and 3 out front? Multiply. Those are just numbers. They're not exponents. They're just numbers. And so when you multiply 5a to some power times negative 3a to some power, the coefficients are just multiplying. So what is 5 times negative 3? Negative 15. Can I be done? No, because I'm not allowed to leave negative exponent. How do I get rid of a negative exponent? Okay, negative exponent goes, since it's currently in the numerator, it's just a regular number, it goes to the denominator. So what is it that goes to the denominator? Okay, a to the negative 1 goes to the denominator, becomes a to the positive 1. Now, I haven't addressed the negative 15 issue. What are we doing with the negative 15? Okay. Or if we think top or bottom, does negative 15 have a negative exponent? No. It's a negative number, but does it have a negative exponent? No. So where should it go in terms of top or bottom? It's going to stay on top because you're allowed to have a negative number. You're just not allowed to have a negative number in the exponent. Okay. Now, I think, Carolyn, you said something about negative 15 times 1 over a to the first. That's equivalent, but not a very nice form to leave it in. It'd be better if you could put it all as one fraction. Okay? About the only thing you can do to make this better is, do we have to have a to the first on bottom? If you want to, you could just write that as a. So, negative 15 over a. I have no problem if you leave it as a to the first on the bottom. I want to say I don't think MathXL will count you wrong if you leave a power of 1, but as soon as I say that, I start questioning myself. So I can't guarantee that. Okay? Questions on what we just did there? That sounds familiar at least, right? Not saying you could have gotten it right just out of the blue, but I'd like to think we could have had a decent run at it. Okay, let's try B. Negative 4, x to the negative third, y to the fifth, raised to the second. Okay, that 2 that is outside the parentheses has to go with, we have to square what's in the parentheses, right? These pieces are all being multiplied. So that means that 2 goes with everything. If I start at the end, it's going to go with the y to the fifth. It's also going to go with the x to the negative third. And what else is it going to go with? That negative 4. So think of that as not just 2 things, because I know some of you tagged that negative 4 and x together. Think of it as 3 things. There's a number there, the negative 4. There's an x, and there's a y. And it has to square all of those. So, what is negative 4 squared? 16. And remember, guys, it's just doing negative 4 times negative 4, which is positive 16. Okay? What about x? What do you do with a power raised to the power? It's x to the negative third raised to the second. We're going to multiply them. Think of it as x to the negative third raised to the second. It's a power raised to a power. So you multiply them. It's x to the negative 6th. And what about y then? Multiply. It's a power raised to a power, so it's y to the 10th. And when I say power raised to a power, think of it this way. There's just one y, but 2 powers. So I'm going to multiply. Am I done? No, because I can't leave negative exponent. What's my final answer going to be after I get rid of that negative exponent? Going with you know what he's trying to say. Do we agree?
Sure.
Here's the deal, guys. That negative exponent, how do we get rid of it? It moves to the denominator. Does anything else move with it? No, nothing else has a negative exponent. So 16 stays on top, and y to the 10th stays on top. So 16 y to the 10th over x to the 6th. Okay, C. 4a b to the 6th, c to the 3rd, divided by a to the 5th, b, c to the 3rd. Any thoughts on where to begin here?
Since it's c to the 3rd on top and bottom,
Okay. C to the 3rd, top and bottom. What happens when you have two of the same things, top and bottom? They cancel, right? What if this had been 5 divided by 5? What's 5 divided by 5? It's a 1, right? So they essentially cancel each other out. So you can, if you want, automatically think of those canceling out. Or think of it, when you divide something by itself, right? C to the 3rd divided by c to the 3rd. Gentlemen, focus here. Now, it's all the big division problem, yes? Okay, think of it as division. First of all, we've got a whole number 4 out front. What does 4 divide with? Are there any whole numbers on the bottom? No, so you can either think of the 4 as staying or it's 4 divided by the invisible 1. So that whole number of 4 just stays 4. What about A's? I've got A and A to the 5th. What are you going to say?
you have to move the a to the 5th up and then subtract.
Okay, one way to look at it. Okay, he says move the a to the 5th up, and when you move it up, it becomes a negative 5, and then you add 1 plus negative 5. How about, what's our rule for dividing? You just subtract. So with that, so it ends up being the same thing. So remember there's an invisible 1 on the a, and 1 minus 5 is? Negative 4. So the whole number 4 stays. You subtract to get a's and negative 4. What about b's? 6 minus the invisible 1 makes it b to the 5th. Now, if you didn't catch that the c's canceled, let me ask a question. What is 3 minus 3? 0. So if you didn't catch that the c's canceled, you would now be at the point that it's c to the 0. But what did we talk about? Anything raised to the 0 is 1. So you would just drop that out. Okay? Am I done? Negative exponent. Where's the negative exponent go to become positive? To the denominator. So what's my final answer read?
4b to the 5th over a.
Okay. 4b to the 5th over a to the 4th. 4 was positive, it stays. B to the 5th is positive, it stays. A to the 4th moves to the denominator to become positive. Okay. As we go through this chapter, we're going to have to know those exponent rules we're reviewing there. Okay, those are just part of working in algebra, is that you kind of have to know your exponent rules. So hopefully those seem somewhat familiar. We'll keep working on them. Okay. We are talking about roots and radical expressions. Now, we actually kind of have two different sections here, but these first ones, it's asking me to find all real roots. So if you recall from last chapter, so last chapter was chapter before, I think it was chapter 4. We learned imaginary numbers, yes? Okay. Imaginary numbers have no place in this chapter. Okay? Unless I'm forgetting something. Unless I'm forgetting something like later on. But generally speaking, what we're doing here for the most part of the chapter, I'm not talking imaginaries. So what happens then if I ask you to take the square root of a negative number? Can you take the square root of a negative number? No. Okay? So you're only being asked to find real roots here. Okay? Now, the key is that we're not just talking square roots. We're doing a little bit of everything. I think in Algebra 1, you probably focused more on square roots. You did a little bit of the others, so it was more of a square root focus. Here we do a little bit of everything. So, A, note the question, what are the real cube roots? And then there's 3 problems there. So 8 thousandths, negative 1,000, and 1/27. So what's it mean to find a cube root? Okay, so we're not doing a square root here, I'm doing a cube root. So I have to multiply 3 times. Now, as I look at 0.008, and I wouldn't always just jump to the calculator here, okay? But think about 8. Do you know a cube root of 8? 2 times 2 is 4, times 2 is 8. And I'll give you guys some cheat sheets as we go at certain points in the chapter. But so can we agree the cube root of 8 is 2? So what about the cube root of 0.008? Not exactly. Why 0.2 as opposed to 0.002?
You're dividing it, so more zeros.
Okay. Think about when we start multiplying. Okay. Jace gave me the perfect normal answer. I want to hear that. What happens when you do 0.002 times 0.002? How many decimal places do I now have? When I have 0.3 decimal places times 3 decimal places, what happens? That becomes 6 decimal places because you have to count over all those decimals. And then when you multiply by another 0.002, now you're at 9 decimal places. Is this 9 decimal places with that 0.008? No. Okay? So you can kind of think of dividing it out in that there's 3 decimal places currently. So this is a cube root. So that means 1 decimal per multiplication step. I'm not sure how to say that. That's not. Yeah. I guess the key here is getting you trying to think about what raised to the 3rd power. Okay? And that is the idea 0.2. Now, could your calculator tell you this also? Yes. You can do cube roots on a scientific calculator. Okay? It's just a matter of knowing how. So your calculator can definitely tell you this. However, thinking forward to things like ISEP and stuff, it's also good to be able to figure out what they're asking there without using the calculator on something like that. Okay, so we can agree that the cube root of 0.008 is 0.2. check myself. Can you multiply it together? 0.2 times 0.2 times 0.2? Just trying to give you thoughts here. Okay. Next one we're doing is cube root of negative 1,000. So what you're asking yourself is what can I multiply together 3 times to get negative 1,000? Think about it, guys. Does that make sense? Okay. And this is where we have to work it out, right? So they're suggesting the answer is negative 10. I'm just doing this to prove because I can guarantee some people out there saying it can't be negative. Yes, it can. Negative 10 times negative 10 is positive 100. So then, 10 times 100, add your zeros. It's 1,000. Positive times negative, it's a negative. Cube roots are different than square roots, right? When we're talking odd roots, so third roots, fifth roots, seventh roots, ninth roots, anything crazy like that, you can have a negative. So the cube root of negative 1,000 is negative 10. What if it had been the cube root of positive 1,000? It'd be positive 10. So realizing cube roots, your answer has the same sign as the original problem. And then we have one more, don't we? Okay. 1/27. So before anyone says anything, here are my hints. First of all, don't go to the calculator on this one. Well, I guess you could with pieces of it. But yes, it's a fraction. That doesn't make it scary. Think about the numerator only. Do you know the cube root of 1? And then think about your denominator only. Do you know or can you find the cube root of 27? And if you can answer yes to both of those questions, we can take a cube root. Okay, have you thought? Can you do the cube root of 1? Any root of 1 is 1, right? So the cube root of 1 is 1. 27. This is a good one to know, guys. 3 times 3 is 9. Times 3 is 27. So with that in mind, what is the cube root of 1/27? 1/3. So don't let to me, the fractions are probably easier than the decimals, honestly. Okay? So cube root of 1/27 is 1/3. Okay, questions on my cube root problems. Let's try some fourth roots. What are the real fourth roots of 1, negative 1/10,000, and 16/81st? So, and notice again, remember we're talking real. So the real fourth roots of 1. What? Okay, so can we agree that 1 to the 4th is 1? 1 times 1 times 1 times 1? Got any other answers for me? Negative 1. Negative 1 times negative 1 is positive 1. Times another negative 1 takes it back to negative. Times another negative 1 takes it to positive. Or what is a negative raised to an even power? It's always positive. So, what are the real fourth roots of 1? How about if I say plus or minus 1? Okay. And notice, they didn't give me a radical initially. We'll talk about how that would make it different here in a moment. But they're asking me for the real fourth roots, so any roots. So make sure, anytime it's an even root. So if it's a square root, you better tell me plus or minus. If it's a fourth root, you better tell me plus or minus. If it's a sixth root, Tell me plus or minus. You get the picture? Okay. So now, -1 10,000th. What are your thoughts here for the fourth root of -1 10,000th? What's the catch? Yeah. If I take 4 of anything, can I take 4 of anything and multiply to get a negative? No. 4 positives multiply to be a positive. We just talked about 4 negatives. What do 4 negatives multiply to be? A positive. Am I allowed to talk I today? No. They're only asking real. So are there any real fourth roots? No. So there are no real roots. Notice I didn't say just no roots. I said no real roots. Okay? What would your calculator tell you if you tried to do the fourth root of that? Some kind of error, right? Depending on your calculator. Do you guys know how to do a fourth root on your calculator if you need it? If you use the calculator like this one, and even if you don't, scientific calculators, you're still looking for the same thing. On mine, I have to enter my 4 first if I want to do fourth root. But do you see right here above my caret, my exponent button, I have an X root button? If I do my X root, what that's done right there, because I typed the 4 first, is that saying whatever I do next, I'm going to be doing the fourth root of it. So if I do the fourth root of -0.0001, guess what? There's an error. Domain error means you can't have a negative in the domain. If I took this negative off, I heard some of you guessing. Did you guess the right answer if it wouldn't have been negative? Yeah. The fourth root of 0.0001 is 0.1. Notice 4 decimal places, fourth root, so it's 1 decimal per root. Okay, so if you get stuck on how to use your calculator or something, let me know. I can usually figure it out. Okay, Casios are backwards to me, but I can usually figure them out. I don't know. Someone does. I don't know. Is your calculator okay, Lily? Have I said something to you before? There's a calculator. I don't know if I have an example in my drawer or not. Is this it? There's a calculator some of you won't be able to use. Okay. The TI-30XS. Do you have the TI-30XS? You won't be able to use it on quiz and a test. Because when we get to a certain part of this chapter, it does too much. When my calculator will tell me that the square root of 20 is 2 square root of 5, you can't use it. Now, that's another lesson for another day. But I'm just going to give you, I'll show you why you won't be able to use it and explain. Okay? So, giving you a heads up, be familiar with another calculator along the way because I can't let you use it on test, okay? So, okay. Can you do the last one? Okay, guys. The fourth root of 16 over 81. Don't plug the whole fraction into a calculator and take the fourth root. That'll give you some yucky decimal answer. We don't want that. Think individual numbers. If you have to plug into a calculator, plug individually. Fourth root of 16. Can you come up with something that we multiply 4 times to get 16? 2. Remember, it was 3 to get 8, right? 2 times 2 is 4, times 2 is 8, times another 2 is 16. So the fourth root of 16 is 2. What about 81?
3.
It's 3. And if you're saying, whoa, how'd they know this? You'll get to know some of the basic ones as we go. With 3s, here's what I think. 3 times 3 is 9. Another 3 times 3 is 9. 9 times 9 is 81. So, Huh?
You said 9 times 9 is 20.
Yeah, I did 9 times 3.
Okay. So the fourth root of 16 over 81 is 2/3. Okay. Are you getting how to think through some of this? I mean, it's not, I don't know, you just have to be careful. Okay, next question. What are the real fifth roots of 0, -1, and 32? Okay. Fifth root of 0.
0.
Officially, I think the calculator will give it to you a 0 on it.
Type in 0.
Okay, you haven't figured out how to use your calculator. Your calculator probably works backwards. I'll have to look at it too. So, well, that's the thing. Your calculator works really backwards. So where's your phone? Okay, so,
Because like I did the last one with 4, like the 0, this number, when I give me a number. Like,
okay, so in your calculator, what are you trying to do?
I was trying to do this one.
Okay, let's do the 4th root of 81. So I'm doing the 4th root of 81. So you do fully opposite. 81. This button, and then what root do you want?
Oh, okay. I have to follow backwards.
Yeah. Yes. Maybe. Okay, guys. I messed up. Did you guys hear my mess up?
No. It's all wrong.
No.
It's all wrong.
Okay, guys. What kind of root were we doing here? It's my mess up. I'll claim it. It's a 4th root. What do we know about second roots or square roots, 4th roots, 6th roots? Plus or minus. So really what this should have said, plus or minus 2/3. And I just X'd it because I didn't have enough room to write plus or minus the way I did my box. So. Oh well, that's my mistake. Thank you though, definitely. Just goes to show what mistakes are you guys going to make? Learn from my mistake and don't make it. How's that? Learn from my mistake and there we go. You got it out of your system. You don't have to make it now. Okay, fifth roots. Did you guys have a thought on the fifth root of 0? I think you did. Fifth root of 0 is 0. Okay, any root of 0 is 0. What about the fifth root of -1? -1? Now think about it. Does that make, first of all, with cube roots, odd roots, right? When you take the root of a negative, your answer is a negative. And what's any root of 1? 1. So the fifth root of -1 is -1. If you don't believe it, check yourself. Do -1 times -1 times -1 times -1 times -1. Okay? Yeah, it's a lot, but. Okay. And this is a good one to just know. Fifth root of 32. Do we know it? 2. Was 8. 2 to the 4th was 16. And 2 to the 5th is 32. Okay. And now we finally get down to square roots. What are the, notice, real square roots of 0.01? Well, think with me, guys. First of all, I see a 1. What's the square root of 1? A 1. Now, we have to figure out where to put the decimal. There's 2 decimal places there. I'm taking a square root, which is a power of 2. So I think of it as 2 divided by 2. Now I have 1 decimal place. So this is 0.1. We're doing a square root. Notice I left space this time. I didn't forget this time. plus or minus. Okay? And guess what? Math Excel is going to tell you when you forget that plus or minus, aren't they? Right, because Mrs. Sargent already took care of that mistake for you. Did I save it? Nope. Okay, square root of -1. Square root of -1 was what? Okay. No real roots. Because we're back to even roots, and you cannot take an even root of a negative. So no real roots. Square root of 36 over 121. Square root of 36 is 6. Square root of 121, you know it, right? 11. Did anyone say it? Okay, now. Okay, I'm going to write a note off to the side here. Okay, so first of all, odd roots. Okay, I'm just kind of trying to write a shortcut here for you. Odd roots, so third roots, fifth roots, seventh roots. How many answers do they have?
One answer.
Just one answer, right? And what do you know about the sign?
It matches with what you're answering.
Okay, if you take the odd root of a positive, your answer is positive. If you take the odd root of a negative, your answer is negative. So 2 things to know about odd roots. There is always one real root, and the sign matches the base, as in the original problem there. Okay, so that's kind of your synopsis of how we do odd roots. So now, even. What do you know? How many solutions? 2, as long as your base was positive. What if your base is negative? None of them. Okay, so what I'm writing right here, positive base equals 2 real solutions. And that's the plus or minus. Whoops. Negative base equals no real roots. Now, okay, listen. Yes, your math menu will help you with square roots and cube roots. Math menu. Okay, guys. Looks like it'll have to be tomorrow, but I'm going to tell you, there's a difference of how we do it when they give us a radical here, and the radical is present, and they're asking you to find the square root. Okay, so we'll talk about that tomorrow. You're welcome to start homework. We have some absolute value stuff to talk about on the back side, so we'll finish that tomorrow.
Okay, so homework won't be due tomorrow.
No, homework is not due tomorrow.
Yes.